Okay, so a couple of properties about polynomial equations that we need to just keep in mind as we're processing through here is, first off, if a polynomial equation is of degree n, so remember that the degree is the highest power. So if its biggest power is 3, then counting multiple roots separately or individually, then it will have n roots, or in that, when I said n is 3, then it would have 3. Now, that doesn't mean they're all different. It could be the same root. Think back to our multiplicity stuff. That multiplicity, when we added up all those multiplicities, would be the same as the degree. So it's not saying that they're all different. It's just if we were to separate them all out. Now, the other thing is that if a plus bi, so a complex number, if it's in that format, if we have a complex number is a root of a polynomial equation, then its conjugate, its complementary, or its complex conjugate will also be a root. Okay, they always happen in conjugate pairs. Okay, so if you get one, you automatically get the other. Kind of buy one, get one free. Now, the other thing is kind of what algebra is completely centered around is if you take a polynomial and you set it equal to 0, there is at least one complex root. Now, complex is kind of the biggest, broadest, encapsulates every type of number there could be. But when we state it up that high, then we guarantee we've got all the kind of prettier ones as well. So it has at least one complex root solution, okay? So we've got kind of a couple things here. We've got one, whatever that biggest power is, that is the number of roots that we're going to have. That's helpful to make sure that we're not looking for extras when they're not there. The second was if you have a complex number, its complex conjugate is also a root automatically. And now we've established that any polynomial set equal to 0 will have a solution.